bounds of the camera are going to be from our camera 2D. So here in our player scene, if you look at the camera 2D, in the inspector, you can see there's a section called limit. Also within the camera, if we look down here in the inspector, there's an option, there's a section called editor, and draw screen is already on. That draws that purple box that shows what the screen, is what's going to render to the screen. Let's go ahead and click draw limits on. And you're not going to see anything right away because the limits are set to these really high values within our playground right now, because the way we control our game, and I'm sure you've seen this and noticed this, but if we walk past the edge of our tile map, right, our player can just keep going. And we don't even want to see the edge of our tile map, obviously. We want our camera to stop when it reaches the edge. So we're going to set that up. Now, we can't really do anything within our playground right now because the way we control the bounds of the camera are going to be from our camera 2D. So here in our player scene, if you look at the camera 2D, in the inspector, you can see there's a section called limit. Also within the camera, if we look in the inspector, you can see there's a section called limit. Also within the camera, if we look down here in the inspector, there's an option, there's a section called editor. And draw screen is already on. That draws that purple box that shows what the screen, is what's going to render to the screen. Let's go ahead and click draw limits on. And you're not going to see anything right away because the limits are set to these really high values, right? I don't know if it's 1,000,000 or what, but let's just set the left limit to like -500. And if I zoom out, you can see a yellow line appeared there. We'll do the same thing for the top, maybe a little bit smaller, maybe even smaller still. You can see it just poking through there. -300, right, we'll go 500, and bottom we'll go 300. Okay, so now we've got this yellow box. That's going to limit the movement of the camera. It's not going to be able to move without those limits. And obviously this isn't super helpful doing this from the player because we can't see the map, but let's just go ahead and test it anyways. Okay, so if I move, at some point the camera should stop. Oh, there it goes. Okay, it was outside the tile map, but it's working. And if I go to the right and the bottom, you see the bottom and the right are stopping. Because obviously we've set these values just arbitrarily looking at the player scene, and that doesn't really jive with what we're doing. So I'm going to just reset all those. So what we want to do is we want to be able to set those automatically based on the size and shape of the tile map that we've drawn in our main scene. Okay, so that's the problem, and that's what we're going to solve today. Let's go ahead and start then by creating a new script for our player camera. So let's just navigate inside of our player folder, inside of scripts, and let's create a new script in here. I'm going to go ahead and call this, I don't know, player camera script. Okay. And we should at some point reorganize this folder, but anyways, player camera script. Let's go ahead and drag that onto the camera here in our scene. Open that up. Like usual, let's give it a class name that matches. And this is going to extend camera 2D, right? Because that's the kind of node we're putting it on. And that's the kind of node whose functionality we want to manipulate. Now, this script is going to be pretty straightforward. We're not going to need this process, so let's go ahead and just remove that. And we'll create a new function called update limits. We'll not need to return anything. And what this is going to do, if you recall, when we selected our camera, we were manipulating these limits here. We're just going to update these. In order to do so, we're going to pass in some bounds of the tile map. And the way I determined I would retrieve these is by passing in some vector 2s. So this is going to expect an array of vector 2 variables. And then we're simply, let's see, why am I getting I spelled vector 2 wrong, okay? So then what we're going to do is just go to our limit left. And that's going to equal, and we're going to convert to an integer because these limits are integer values, okay? So I don't know, I don't think we can pass in a float. It might convert if we did, but they're expecting an int. So we're going to take the bounds array that we pass in, and we're going to grab the first item and get the x coordinate for the left. And I'm going to go ahead and copy this line, just paste it a couple times here. So next we're going to go, the top is going to be the y of that first item. So the first vector 2 is the top left corner that we pass in, and then we're going to get the bottom right corner and pass that in as the second vector 2. So that'll be item index 1 in the array. And so this will be right, and this will be bottom. And let me just double check this. So we've got limit left is the x of the first one, limit top is the y of the first one, limit right is x of the second. I know saying first and second when the numbers don't match is weird. And then limit bottom should be the y coordinate. Okay, so that's all that this needs to do. What we'll do is we'll pass in the two vectors, the two vector 2s, and then it'll just update the limits of the camera. Okay, pretty straightforward. We are going to have to update the script just a little bit more before we can pass those in, but for now this is sufficient. We'll just get started with that and make sure that you've added that to your camera. So now that we've created this script, we need a way to be able to pass this data in or to be able to call this function. But we don't want to have to hard code any connection to the camera because in the future we're going to be changing levels. The tile map is going to change. And so we need a way for any new tile map to just be able to automatically connect. And so for that purpose today, we're going to create a special script that will help connect our levels to our camera and help them communicate. We don't want to have the camera or the level to have direct reference to each other. So pretty straightforward, I hope. An auto load script in Godot is like a singleton. If you're familiar with the singleton pattern, we design a class that's intended to be instantiated once in the software, in the program, and then any other class can access it if they need to access its data or use its functions, right? So let's start by creating a new folder, and we'll go through and describe what an auto load script is. And I guess you could create a folder called auto loads, but I always use 2 zeros so that it's always at the top of my list. And I like to call these scripts global scripts. So I'm going to create a folder called globals, 00_globals. And then in here, let's just create a new script. I'm going to call this script global level manager. So hopefully the name infers that it's going to be responsible for just managing level type information and data. Now, one thing that we normally do is give a class name. With an auto load script, we're not going to do that. Okay. It will get us a unique name, but we're going to implement that in the project settings here in just a moment. But before we do that, let's see. Let's just go ahead and set this up a little bit. I'm going to remove the ready and the process functions from the script. And we're going to give it a few things here. So one thing that we want is we want to keep track of the current tile map bounds just in case we need it. And actually, this is going to come in handy. We're going to need to access this the first time we start the game. Remember, what we're passing in is an array of vector 2s. And we're really only interested in having 2, but just for simplicity, it's just an array. Now, this also needs a signal so that we can connect to this signal to see anytime the tile map bounds change. So tile map bounds changed, right? And this signal will emit that same kind of data, right? I'm just going to go ahead and copy that, paste it here. Okay, so it's going to emit the same kind of data. And we're going to create one function, and it's going to be change tile map bounds. And this is going to return void. And actually this change tile map bounds is going to require the same parameters as an argument. And it's going to be pretty simple. We're just, essentially what we're going to do is we're going to look at our tile map, and anytime we load a new tile map, it's going to call this global script, and it's going to call this function, and it's going to pass in its own bounds. We'll do that next, but just keep that in mind. That's the flow. So what change tile map bounds is going to do is it's going to update our current tile map bounds to equal the bounds. Okay. And then it's also going to take our tile map bounds changed signal and emit the new bounds so that anybody listening will be able to grab them. So there's two ways that we can get these bounds then from this global script. One is we could just query them directly, or we can connect to this signal and get it from that. Now, the last thing we need to do though with this auto load script is we need to set it up. So in order to do that, we go into project settings, and there is a tab in here called auto load. And what we can do here is just click on this folder and go into our globals folder and select global level manager. And I'm going to remove global from the name, just call it level manager, and add it. And now you can see we've got this level manager and add it. And now you can see we've got this level manager name, and it's referencing the script. You can see we've from the name, just call it level manager. And I'm going to remove global from the name, just call it level manager, and add it. And now you can see we've got this level manager name, and it's referencing the script we just created, and it's enabled. And that means that it's going to be loaded anytime you run the project. This class, this script, is going to be loaded on a node. So I'm going to go ahead and close that. And there we go. That's our level manager. And in the future, we'll probably add some extra items to this. But for now, this is all we need, is this ability to update the tile map bounds. We're going to need to set up a script that we can apply to our tile map scene that we have our grass on. And this is going to allow us to call this, right? So let's create a new script. Let's find our tile maps folder. Okay, tile maps, there we go. And I'm just going to create a script in the root of this. There we go. Maps folder. Okay, tile maps, there we go. And I'm just going to create a script in the root of this. I think we'll call it level tile map. Go ahead and click OK, create that. Let's open our grass scene. Okay, OK. I think we'll call it level tile map. Go ahead and click OK, create that. Let's open our grass scene. Okay. So remember the grass scene, we don't display anything by default, right? But this is the scene and the root is a tile map. Let's go ahead and drag this level tile map script onto our grass scene so that it'll utilize it and open this guy up. And let's add some GD script here. So the class name, we'll call this level tile map, and it's going to extend tile map. Now we will use the ready function. We don't need a process call. We just need to create a function in here. We could do this all in the ready function, but it's good to separate functionality out. So let's create a function called get tile map bounds. And this should return that exact kind of object that we're expecting, right? An array of vector 2s. Okay. So let's go ahead and just set this up like this. Let's declare a variable on the first line, and that'll be our bounds, and it'll be an array. We're typing this one line a lot. I probably still have it copied in my clipboard, but anyways. Okay, so that'll be an array of vector 2s, and we'll just set it equal to an empty array. And then just to get rid of this error, let's go to the last line of our script and just say return bounds. Okay. Now, in order to get the bounds, we're going to, since bounds is an array, we're going to append an item to it. Okay, now this item needs to be of type vector 2, so we're going to make a new vector 2. Right? And it's going to have an X and a Y component that we're going to pull from our tile map. Now, tile maps have some built-in functions that we can use to get the data that we need. So we can say get used rect. That's the rectangle that contains all of the tiles in this tile map. And to get the X and Y coordinates on this, we can just say get the position. But there's one minor issue here. The position is going to be in tiles. And if you remember, our tiles are 32 pixels by 32 pixels. So we need our vector 2s to be that pixel number, not the tile number. So in other words, if we're looking at our tile map here, and let's say we draw this, okay, this is 64 pixels by 64 pixels, right? Because each square is 32 pixels. But that script that we wrote right now, get the used rectangle dot position, the position is going to be in terms of tiles, not pixels. Okay, so I hope that makes sense. So but there's a simple thing we can do, and we can just multiply this number then by the size of our tiles, which is 32. But we don't even have to do that because if you changed, let's say you changed the size of your tiles, or you had a different tile map that had different size tiles, then we wouldn't want it to break. So there's this parameter called rendering quadrant size, and that's going to be the size that we set for our pixels. So if we look at the tile size here in the inspector, if you look at your tile map and open up the tile set, it's 32 by 32. Actually, no, it's this rendering quadrant size. Ooh, I'm glad I did that. We set the tile size here to 32. This should also be set to 32 to match. So good catch. I think I had done this in my testing project, but we overlooked it when we set this one up originally. So just make sure that that's 32. This number is what we're going to pull in right here to multiply to get our vector 2. Okay. So that's our first vector 2. That's the top left corner, the position. This get used rect, the position, always refers to the top left corner of your drawn tiles, right? Top left corner. It doesn't matter where it is. It could be outside of the order. It's going to be right up here. Okay. So let's go back to our script and let's just append one more. And this is also going to be a vector 2, right? This one we're going to do a little bit differently, but we're going to use the get used rectangle again. Get used rect. And this time we want the end. Okay? And the end is just the bottom right corner, essentially, of the bounding box. And once again, we do need to multiply this by the rendering quadrant size. Okay. So this will be our two vectors. We're grabbing them, we're shoving them into this array, and we put them in this specific order, the top left, bottom right, and that way we'll get them in the order that we need for our other script. And then we just return this. So the last thing we need to do here is we need to call our auto load script, which we called level manager. You notice how that auto completed for me. Level manager is recognized by Godot that has a script that auto loads. And then if I put a period and start typing, well, it's not recognizing change tile map bounds right now. Sometimes it'll do this, sometimes it won't. Maybe if we run the project once it will. Okay, so we're gonna call that function, and we're gonna just pass in the values that we get from this other function we wrote. We're just about actually done going all the way through, but you can see when a tile map loads on its onReady function, it's going to figure out its top left and bottom right corners, pass them into our level manager script. Our level manager script is going to store it here, and then it's going to emit it through the signal. And that leaves us just one more step. Let's go all the way back to our player camera script, and we just need to make this come full circle, right? Because we still haven't connected this here in our player camera script. And actually, it's going to be pretty simple. As soon as this player camera initializes, we want to call the level manager and get the tile map bounds changed. See, it recognize that signal. Don't know why I didn't recognize the function. And we're just going to connect to that signal, and we'll just connect our update limits method. There we go. So anytime that signal fires, it's going to run this. It's going to update the limits. Now, there is a minor flaw. The very first time that the project runs, this script's onReady function is going to happen after the autoload scripts. And I mean, there's maybe things we could do to try and force them to load in a certain order. I think that's a little bit unnecessary. It's quite simple that we can just call update limits, and we can just pass in the level manager and get the current, what do we call it? Current tile map bounds. I think that's what we called it. Let's just go to our level manager script. I'm gonna go ahead and copy that. Go back to player camera. It looks like it's seeing it. It looks fine. Okay, yeah. So what this will do is we're gonna connect, and anytime that fires, we'll update them, but we're also gonna force it to update the very first time we run the script. Okay, so it's gonna try and get those no matter what, even if we miss the signal. And then any future signals that come through, we'll just pick them up and run them as is. Okay, which will be really handy when we do things like loading new levels with new tile maps. So hopefully everything is coded up correctly. I'm gonna go ahead and just run the project. And if we did, we shouldn't be able to see the camera. Uh-oh, got an error. That's good. It's good to have errors every now and then. Let's see. Can't get index 0. It's out of range. Okay, it looks like maybe we have a situation where we don't have any level bound set. Interesting. So what looks like is happening is we're calling the update limits, and we're not passing in any bounds. And I'm guessing it's this one here is calling, and we're actually calling before the level manager has received the bounds from the tile map. So this is good. This is something I didn't catch when I was practicing this, and I think again, this depends on the order in which things are loaded. So the reason I had stored the current tile map bounds is because typically when I was prepping for this, I was seeing that the tile map would load and then this signal would emit before the player loaded. But I'm guessing that the order in which we've inserted these into the playground here is different than I've done when I was practicing. Like here, the player is first in the list. If I drag it down, then this might actually run without any errors. Let's give that a test. Yeah, there we go. Okay. But we don't want to assume that they're going to come in any order. So this is good that we did this. We just need to do one more bit of safety here. So let's just add an if statement. And if our bounds is an empty array, then we're just going to return the function. We're not going to try and update them because that's the error that we were getting. So let's go ahead and run this one more time. And let's check it out. Should all be working now. So here's our player. And if I walk to the side, there we go. Look at that. Camera stopped. It should be true if I go down to the bottom and to the right. Now I know there's something that's going to happen here. Well, we've got this little piece sticking out, so our bounds are out there, so we can fix that. But everything's working as intended with that one minor issue. We just have to come over here to our playground, go to 2D, select our tile map, and let's just right-click to delete that little guy. In order to do that, you need to make sure you're on the draw mode. There we go. And so you'll notice that demonstrated that the bounds is going to go. If we were to draw some grass way out here, then that rectangle is going to encompass those. So we want to make sure our tile map that uses this script is nice and clean and doesn't have anything sticking out from it. So there we go. We've done a very simple implementation of automatically applying some bounds to our camera for each of our levels, and we'll be able to utilize this in the future as we move forward. And I hope you guys learned something new as well, and we'll see you next time. In this video, we're going to create a simple slime enemy, start building a slightly more flexible state machine for our enemies, and create the idle and wandering states that we'll use to start building our slime. Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GDScript. Okay, so let's start by setting up our folder structure and getting everything ready for the enemy assets that we're going to be working with. We'll start by, in our resources, let's just create a new folder here. We'll call it enemies. I can remember how to spell that. Okay, so we'll put all of our enemy-related things in here. Let's add another folder underneath it for our scripts. And let's see, we're going to have one enemy that we'll create. We'll create a folder for this enemy. We're going to create a slime enemy. Okay. And then we're going to want to open our slime enemy folder in the file manager and then grab our tutorial asset that you can download from my itch.io page. Just plop that in there. And now we've got our slime sprite sheet in here. So everything should be set up to get going. Okay, now that we've got our folder structure set up here and everything ready, let's go ahead and actually create a new scene for our slime enemy. And I'm doing that in the slime folder here. Call it slime. Okay, there we go. The slime actually shouldn't be a node 2D though, so let's click on this and let's change the type to be a character body 2D. Structure set up here. Everything should be set up to get going. Okay, now that we've got in this video, I'm going to show you how we can set up a simple auto-load script and use it to set our camera limits based on the level's tile map. Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GDScript. So let's have a look at our project and kind of get a feel for the issue that we're going to solve today. But when we run our game, and I'm sure you've seen this and noticed this, but if we walk past the edge of our tile map, right, our player can just keep going. And we don't even want to see the edge of our tile map, obviously. We want our camera to stop when it reaches the edge. So we're going to set that up. Now, we can't really do anything within our playground right now because the way we control the bounds of the camera are going to be from our camera 2D. So here in our player scene, if you look at the camera 2D, in the inspector, you can see there's a section called limit. Also within the camera, if we look down here in the inspector, there's an option, there's a section called editor. And draw screen is already on. That draws that purple box. It shows what the screen, is what's going to render to the screen. Let's go ahead and click draw limits on. And you're not going to see anything right away because the limits are set to these really high values, right? I don't know if it's 1,000,000 or what, but let's just set the left limit to like -500. And if I zoom out, you can see a yellow line appeared there. We'll do the same thing for the top, maybe a little bit smaller, maybe even smaller still. You can see it just poking through there. -300, right, we'll go 500, and bottom we'll go 300. Okay, so now we've got this yellow box. That's going to limit the movement of the camera. It's not going to be able to move without those limits. And obviously this isn't super helpful doing this from the player because we can't see the map, but let's just go ahead and test it anyways. Okay, so if I move, at some point the camera should stop. Oh, there it goes. Okay, it was outside the tile map, but it's working. And if I go to the right and the bottom, you see the bottom and the right are stopping. Because obviously we set these values just arbitrarily looking at the player scene, and that doesn't really jive with what we're doing. So I'm going to just reset all those. So what we want to do is we want to be able to set those automatically based on the size and shape of the tile map that we've drawn in our main scene. Okay? So that's the problem, and that's what we're going to solve today. Let's go ahead and start then by creating a new script for our player camera. So let's just navigate inside of our player folder, inside of scripts, and let's create a new script in here. I'm going to go ahead and call this, I don't know, player camera script. Okay. And we should at some point reorganize this folder, but anyways, player camera script. Let's go ahead and drag that onto the camera.
Oh, I forgot my mic wasn't even on, but that was almost exactly to the video. So good shit me.